The factor pairs of 8 are 1 and 8 and 2 and 4. Write all the factor pairs of 42. So remember, a factor of a number means that we can divide it without getting a remainder. And we can think of factors in pairs because 1 times 8 is 8 and 2 times 4 is 8 as well. Now for 42, they've given us 1 and 42 because 1 times 42 is 42. But now 2 times what is 42? Well, that's 21, because if we divide 42 by 2, we get 21. Now we can have 6 and 7, because 6 times 7 is 42, or 42 divided by 6 is 7. But what's our other factor pair? Well, let's see if 3 is a factor of 42. And to see if 3 is a factor, we can divide by 3. And remember, if we don't get a remainder, then it is a factor. So we can use short division and we get 14. So what this tells us is that 42 divided by 3 is 14. So 3 times 14 must be 42. So for our other factor pair, we have 3 and 14. Here are 6 rectangles on a grid. Which 2 rectangles fit together without overlapping to make a square? So remember, with a square, all the sides will be of the same length. But to make our square, we have to rotate shapes. So we can take shape E, and if we rotate it, so turn it this way, and then place it underneath or on top of D, we have a square, because this side is 3 squares, and all of our other sides are 3 squares as well. So shapes D and E can fit together without overlapping to make a square, because shape E can be turned and fit in these 3 squares here. Grace has a rectangle that has sides of 4 centimetres and 5 centimetres. Draw a different rectangle on the centimetre grid below that has the same area. So, with a rectangle, opposite sides are the same length, so we find the area by multiplying the different side lengths, and 4 times 5 is 20. So we need to draw a different rectangle that also has an area of 20 centimetres squared. Now 2 times 10 is 20, so we can draw a rectangle 2 by 10, and it doesn't matter exactly where you draw the rectangle, as long as the sides are 2 centimetres and 10 centimetres. Of course, on the screen that you're watching this on, the sides won't be exactly 10 and 2 centimetres, but the question says it's a centimetre grid, so we need 2 by 10. Here is the net of a cube with no top. The shaded square shows the bottom of the cube. Draw an extra square to make the net of a cube which does have a top. So we know that the shaded shape or the shaded square is the bottom, and then this side and this side here will fold up, and then this face here will fold round, so it will cover this side of the cube. So to make a cube with a top, we could draw an extra square up here because that would fold over the top, or we could have our extra square down here, so it's again going to fold over the top, or we could have it here, or the other place is here, because then when this square folds round, this one will be able to fold over the top. Kim knows that 137 times 28 equals 3,836. Explain how she can use this information to work out this multiplication. So 138 times 28. If we need to find 138 lots or groups of 28, then we just need one more group of 28. So she can add 28 to 3,836, because the next number in the 28 times table will just be 28 more. Here are 5 number cards. Use each card once to make every statement below correct. So we have the numbers 48 to 52, and we want to know which number is a multiple of 3, 4, 5, 6 or 7, and we can only use each card once. Now we know that multiples of 5 always end in a 0 or a 5, so that means 50 has to be the number card that is a multiple of 5. So start with the easier ones. So here I've started with 5 because I know the rule for multiples of 5. Now let's think which of these number cards is a multiple of 6, because we know our 6 times table and that goes beyond 52. Now the only number here that's a multiple of 6 is 48, so that must be our number card here. And we also know our 7 times table past 52, and 49 is the only number card that we have that's in the 7 times table. So now we need to find a multiple of 4 and a multiple of 3. 52 is our multiple of 4 because we know that all multiples of 4 must be even numbers, and the only cards we have left are 51, which is an odd number, and 52. So that means 51 is a multiple of 3. Now 48 is also a multiple of 3, but remember, we can only use each card once, so we need to write 48 as a multiple of 6. And we can check that 52 is a multiple of 4, because when we divide it by 4, we don't get a remainder. We can check that 51 is a multiple of 3, because when we divide it by 3, again, we don't get a remainder, so we know that it is a multiple. Lara chooses a square number. She rounds it to the nearest 100. Her answer is 200. Write all the possible square numbers Lara could have chosen. So we need to remember that a square number is what you get when you multiply a number by itself. But because she's then rounded it to the nearest 100, we need to think, what could her number have been before she rounded it? Well, the square numbers must be between 150 and 249, because remember, to round to the nearest 100, we look at our tens digit, and if it's 5 or more, we round up. So 150 is the lowest number that rounds up to 200, and 249 is the largest number that rounds to 200, because if we look at our tens digit, it's a 4, and with 4 or less, we round down, so the 2 in our hundreds stays the same. But we need a square number, and the largest square number that we know is 144, because we know that 12 times 12 is 144, so multiplying 12 by itself would give 144, but that's less than 150, so it doesn't round to 200. So let's work out 13 times 13, because that will give us a square number as well. So that gives us 169. When you multiply 13 by itself, you get 169, and then that rounds to 200. So one possible number is 169, but we need to write all the possible square numbers Lara could have chosen. So let's work out 14 times 14 and see if that answer rounds to 200 as well. We can use column multiplication for this, and we get 196, which does round to 200, so that's another possible answer. If we work out 15 times 15, again, that's going to give us a square number because it's what we get when we multiply a number by itself. And again, it's between 150 and 249, so 225 rounds to 200 as well. We can work out 16 times 16. That gives us 256, but that would round to 300 because we have a 5 in our tens, so we would round up. So we can't write 256 as one of our possible square numbers. We need to write 169 because that's 13 squared, 196 and 225. Chen and Megan each have a parcel. Chen's parcel weighs 1.5 kilograms. Megan's parcel weighs 1.2 kilograms. How many more grams does Chen's parcel weigh than Megan's parcel? So we know that 1 kilogram is 1,000 grams. So that means that half a kilogram is 500 grams, because half of 1,000 divided by 2 is 500. So Chen's parcel is 1.5 kilograms. So that means it's 1,500 grams. So putting these two together gives us 1,500. Megan's parcel weighs 1.2 kilograms. So we need to work out how many grams there are in 1.2 kilograms. Now when you're given a weight in kilograms that's a decimal, to change it into grams, what you can do is write the decimal but with zeros on the end so that it's got 3 decimal places, 3 digits after the decimal point. And then you can just take out the decimal point, so that's 1,200 grams. And that makes sense because 1.2 is just a little bit more than 1, and 1,200 is a bit more than 1,000. So the question asks us how many more, which means that we're finding the difference. We're comparing two values, so we need to subtract. And 1,500 minus 1,200 is 300. So our answer is 300 grams.